While direct current flows only in one direction, alternating current changes direction with a periodicity. Typical main supply in this region has a frequency of 50 Hz or 50 cycles per second. That means a change in direction of flow of current 50 times every second. That is the frequency of the alternating current in the main supply. If the instantaneous values of current and voltage are plotted on a graph against time elapsed, it is seen as a sinusoidal or sine wave pattern. Sine waveform is used in power transmission because that leads to the most efficient transmission of energy. Inexpensive power inverters for converting direct current to alternating current may use square waves. Time taken for completion of one cycle is known as the period and will be the inverse of the frequency. Wavelength can be determined if the velocity with which the wave travels is known. Though we do not usually calculate the wavelength of main supply, wavelength is an important parameter of radio waves used for amateur radio communications. Radio waves are generated when an alternating current is fed into an antenna. Radio waves travel at the speed of light, which is approximately 300,000 kilometers per second. Most popular amateur radio bands have wavelengths of 40 meter and 20 meter, which will correspond to frequency in the range of 7 MHz and 14 MHz. We have seen that voltage and current values follow the sinusoidal pattern for an alternating current. Peak value is the highest positive or negative amplitude of the sine wave. Average value is the arithmetical average of all instantaneous values in a half cycle of the sinusoidal wave and will be 0.637 times the peak value. Obviously, the arithmetical mean of a full cycle will be 0 as the positive and negative values cancel out. The voltage of an alternating current is often mentioned as the RMS or root mean square value rather than peak or average value. RMS value of an alternating current will correspond to the value of an equivalent direct current, which can produce the same average heating effect in a conductor as the given alternating current. It is calculated by finding the mean of the squares of instantaneous values and then taking the square root. RMS voltage will be equal to peak voltage divided by square root of 2. It will be equal to 0.707 times peak voltage. Simple way to experience the 50 Hz of the alternating current supply voltage is to connect it with a step-down transformer to a loudspeaker. A potentiometer can be used to reduce the current going through the speaker to prevent damage to it. The hum which you are hearing is the hum of the power supply which has been connected to the speaker using a 50 kilo ohms Cermet preset potentiometer, that is to show the hum, AC hum in direct connection from the transformer to the speaker using a potentiometer. You can now see that the hum increases in intensity when the potentiometer resistance is reduced using a screw. That is just to show the type of hum. I have reduced it only half. If I reduce too much, probably the ampli speaker will go off. The advantage of using alternating current for main supply is that it can be easily stepped up and down in voltage using transformers. For long distance transmission, high voltage low current systems are preferred to reduce the resistive loss in transmission lines. In my region, long distance power transmission is over 220 kilovolt, 110 kilovolt or 66 kilovolt tower lines from the generator to substations. From the substation, local distribution is with 11 kilovolt high tension lines and then with 440 volts low tension lines. All these are three-phase lines. A single phase of low tension will give about 230 volt for home use. Here is an illustration of waveforms of different types of currents from Wikipedia. It shows a pulsating current in blue color, direct current in red, variable current in gray, and a sinusoidal alternating current in green. This interesting photograph of city lights illustrates the alternating nature of the supply voltage, which is not obvious to us. Motion blurred image produced by waving the camera during exposure shows the 60 Hz blinking of non-incandescent city lights. The alternating current nature of the mains power is revealed by the dashed appearance of the traces of moving lights.